Okay, review on radicals, and then we got some right triangles we're going to talk about. Now you got to simplify the square root. You just punch it into the calculator, it's wrong, okay? Punch it into the calculator only gives you that. That's irrational, okay? That's because 48 is not a perfect square. There's no integer times itself that gives you that, so you give that the old IRR label, and then divide, okay? And you want to be dividing 48 by the perfect square. So you'd start with 36. So is 48 divisible by 36? No. Is it divisible by 25? No. 16? Yes. It's also divisible by 4, but you have to use 16. You have to divide by the greatest possible square root. So we get 16 times 3. Okay. Square root of 16 times the square root of 3. So the square root of 16 is replaced with 4. So 4 times the square root of 3. Okay, the square root of 144. Now the square root of 144 is not irrational. It equals 12. So you just put 12. You don't have to do all that crap. Okay, the square root of 23. See, square root of 144 is 12. Well, you can go ahead and put that. That's an exact value. The square root of 23 is irrational, okay? It's not a perfect square. So we divide. So first I'd start with 16. Is 23 divisible by 16? No. Is it divisible by 9? Nope. By 4? Nope. So it's only by 1. So when 1's the only thing it divides by, it's just the same thing. So you go ahead and just circle the original problem, because that's already in simplest form. Okay, now we got some more complicated radical expressions, square root expressions, whatever you want to call them, on the next page. We have the square root of 75, x to the 5th y. So we have 3 factors in here. So we want to give each factor its own square root, in which you can always do in multiplication, okay, and simplify the 3 independently. So the square root of 75 is done just like the very first problems that we did in here. 75 is an irrational square root because 75 is not a perfect square. So we divide. We'll start dividing 75 by 64. Decimal. 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 And then I got 3. So I want to rewrite that as the square root of 25 times the square root of 3. Okay, so the square root of 25 becomes 5. So this is equal to 5 times the square root of 3. So I make a square root here, and I know I'll have 5 out and 3 in. But now what about the variables? Well, we're going to break the square root up into even more square roots here, because we have x to the 5th, so that means we have 5 factors of x. And you want to be breaking up the square root once again so that it covers 2 x's at a time. And then this x at the end gets its own square root. And I do that because x times x is x to the 2nd power. Now what happens with a 2nd power when it's covered by a square root? You just get a cancellation and you have a whole factor of x. Same thing here, x times x 2nd power, but with the square root and the 2nd power cancel, and I have x. Okay, and then here I have the square root of x, but there's no 2nd power, so that x stays in its square root. So we have 2 full factors of x, and then a square root factor of x. And this right here, y, I mean that's just y to the 1st power, so just be y. So really it's just the square root over y, okay, and you don't get anything to cancel, okay. That's just what it equals. I really just wrote the identity property because it's not to a power, so it's really already simplified. So I put x 2nd out, and I put x in. Now it looks like that y is under a square root, so we probably better put that y right there, man. Okay, so that's it. 5x to the 2nd times the square root of 3x. Okay, now 8 times the square root of 6, so that's a times 3 times the square root of 6. Okay, this one's kind of a little bit different one than what we've been doing here. Okay, multiplication. Okay, it's all multiplication, so there's 3 steps. Okay, and I'm going to write what the steps are. just observe. Step 1, you multiply the outside coefficients, and at the same time you multiply the square roots. Okay, so 8 times 3 is 24, and then I multiply the square root of 6 times the square root of 6, and that's the square root of 36. Now step 2, you simplify your square root. Well, this one's going to be an easy one to simplify because you see the square root of 36 is not irrational, it equals 6. Okay, so I don't do the division on this one. I cross that out and I put 6 because it's not irrational. So now we have 24 times 6. Now in step 3, simplify the outside. Well, there's no square root, so simplifying the outside is just me taking 24 times 6. It's 144. Okay, there you have it. Okay, now the next one's different. Okay, it looks kind of like this one, but 7 times the square root of 18 plus 3 times the square root of 20. If it's plus, you're looking to get like terms. Okay, so that's when you want to set up your table and check the square roots. They're not the same. See, the 7 and the 3 are your coefficients. They're multiplied by 2 entirely different factors, with the square root of 18 and square root of 20. Now, if they were the same square root, I would be able to add the 7 and 3, but they're not. They're different. So we put 7 times the square root of 18 on this side, and then 3 times the square root of 20 on this side. So I simplify now. So I drop the 7, that just stays there. And the square root of 18, well, is that rational or irrational? It's irrational because it doesn't divide by anything. So I put in the division sign. Okay. So I'm dividing 18 by perfect squares. 16, nope. 9, yes. So I rewrite this, 2 square roots, 9 and 1. And then the answer, I got 2 in the other. So the square root of 9 then turns into 3. Okay, so right next to this 7, where you used to have the square root of 18, now you have 3 times the square root of 2. And then you multiply the outsides. That's 21 square root of 2. So you replace this 7 square root of 18 with 21 square root of 2. Okay, then 3 square root 20. So you drop the 3 and then simplify your square root. Now 20 is not a perfect square, so it must be an irrational square root, because you see if you square root the number 20, it's irrational. It's not an exact number. So you put in the division sign and you start dividing. So 20 divided by 16 decimal. 9 decimal. 4. 4 and 5. So 4, 5. So 2 square root 5. 3 times 2 is 6, and then square root 5. Okay, we have a problem here. We have simplified it, but we don't have like terms here either. So if you don't have like terms after you've done the simplifying, because you see we have the square root of 2 and the square root of 5, we can't add the 21 and the 6. So you go ahead and circle that. That's already in simplest form. Okay. Now, if we got the same square root, then we'd write it down and add the outsides, but we didn't. Okay. Okay, now we have to find the side lengths x and y on these right triangles, 90-degree triangles. Now, this is a special right triangle, and the reason why, because it's special if it's got one of 2 measurement combinations with the angles. This is a 60, 90, 30. Okay, you see it right there, 60, 90, 30. Now remember, those are special because they always form a ratio. So you put your 30 degrees, your 60 degrees, and your 90 degrees. These are ratios, not the actual lengths. The actual lengths are 12 for the hypotenuse, and then the x and y we don't have. Those are the answers. But first we need to use the ratios for a 30, 60, 90 triangle. So, across from your 30 is the side length 1. Okay? Across from the 60 is the square root of 3, and then across from the 90-degree angle, straight across, is 2. So label those. So put a 1 in parentheses next to your x somewhere. Put a Remember to put them in parentheses so you don't get confused. Square root of 3 across from the 60, and then across from the 90-degree angle you put 2. Okay. Okay, now we're ready to set up our proportions. Okay, so find x. Remember, when there's two sides, you want to go with proportions. Now, we don't need the sine, cosine, tangent on the 30, 60, 90, or the 45, 45, 90. Okay, so to find x, team that up with the actual value over the ratio value. And then I'm going to need to team it up with the 12 too. Don't team it up with that. That's for down here. Here, I'll even set this up. So we put team y with the square root of 3. And then we use that 12 2. 12 is the actual, 2 is a ratio. And to both these, now we just cross multiply and divide. Okay, so x, 1 times 12 divided by 2. Well, 1 times 12 is 12. 12 divided by 2 is 6. So x is 6. And if you think about it, it makes sense, because think, 2, 1, 12, 6. So 1 is half of 2, 6 would be half of 12. That's what a ratio is. Now this one's a little bit more complicated. You need to write 12 first times the square root of 3, and then divide by 2. So you can't multiply these. One's a coefficient, one's a square root. But you do need to divide the 12 by the 2, and that's 6. 6 square root 3. Okay, those are your side lengths. Okay, next up, now it's a different kind of special triangle. It's special whenever it's 30, 60, 90, or 45, 45, 90, it's special. So, 45, 45, 90, write those degrees, because those always form a ratio. Okay, so, across from the 45 is 1, and the other 45 is 1, and then 90 is the square root over 2. Okay, now put the ratios with the actual values. So 1, go to the other 45 and put 1, and then here, put the square root of 2. So I'm going to solve for x and y. Now if you think about it, you probably know the answer for x here. If I got 1, 1, then I should have 5 and 5, but I'll carry it out. So 5 over 1. Then down here with the, oh, sorry, my bad. Keep it consistent, x over 1. Sorry about that. And then y over the square root of 2. And then I want to use that side in both these where I actually have the actual value, 5 over 1, 5 over 1. Okay, so 1 times 5 divided by 1. 1 times 5 is 5, divided by 1 is 5. So x equals 5, just like we said. Okay, then here you just write 5 times the square root of 2. You don't multiply that, over 1. And then you divide the 5 by the 1, which is 5. Y equals 5, and then you'd have the square root of 2. Okay. Okay, now find the 3 trig ratios of the angle. Okay. Or no, this is wrong. My bad. Go to this page. I need to be on the right page. Find the 3 trig ratios of the angle theta. Remember, this is known as theta. Okay, so sine, cosine, tangent. So you know you're dealing with the Sohcahtoa. That's the first thing you want to write. And remember, this is sine, cosine, tangent. Okay, now you need to label those. So your H is 20. Now, before you label the O and A, you need to pick your reference. Your reference needs to be the theta symbol, because there's no actual degrees in the other angles, so you don't ever reference the 90. Okay, so that's O. We don't know O, and then A would be 8. Okay, so I know that sine is O over H, the cosine's A over H, and the tangent's O over A. Okay, so with that, we actually know some of these. A is 8, or sorry, let's do sine, O over H. So O we don't know, keep that empty. But the H we know is 20. Now the cosine's A over H. So A is 8 and H is 20. So that answer's done. You don't need to reduce it, okay? It could reduce to 2/5 by dividing both of them by 4, but you can leave it like that. Then O over A. So O is unknown, so keep that empty, and A is 8. Now we still need that one side, okay? Now don't use proportions here. Whenever you need one side, you just need to use the Pythagorean theorem. And that is a squared plus o squared equals h squared. Okay? So a is 8. The o is what we don't know, so keep that as a variable. And the h we know is 20. So 8 to the second, that would be, I'm just going to go down here, 8 times 8 is 64. Remember, o is a variable, that's not a 0, it's a variable o. And then 20 to the second is 20 times 20, which is 400. Okay, now solve for the o. You use the linear properties, so you get rid of the 64. Take it to the other side. Okay, and 400 minus 64 is 336. Okay, now find the square root of 336, okay? Well, it's irrational because it's not a perfect square. You can either look on your sheet or punch it into a calculator. That's obviously irrational because you get decimals, so IRR. So I guess you got some dividing to do. So 336 divided by 324 decimal. 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 Decimal, 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 oh, decimal, decimal. Okay, 16 works, so put the square root times the square root, and then it'd be 16 times 21. So the square root of 16 is 4, so your O is equal to 4 times the square root of 21. And that's your exact answer. Done. Now if you wanted to, you could reduce the 4 over 20 by dividing by 4, and you'd end up with the square root of 21 over 5, 1 square root of 21. You could divide these by 4 and it'd be 1 square root of 21, or the square root of 21 over 8, but I'm not going to mandate that. Okay, I need to change the directions in this one. You got to find the 3 sides and angles is what that should say. Okay, so the sides and the angles. So you obviously are going to need your Sohcahtoa because it's not a 36. It kind of looks like those ones we did, but it's not 30, 60, 90. It's not 45, 45, 90. So it's not special. It's just a random degree measurement. It's not special. Well, random, you need to use your A, O, and H. Okay, so there's H. Now you got to put what your reference is. This time it's not the theta symbol. That's not there. Instead of a theta symbol, we have 37 degrees. Okay, so 37 is my reference. So across from there's O, which we don't know. And then my A, I do know. I know my A is 12. Okay. Okay, so now we have to find the O and the H. So I need 2 sides. I know only one side. I need 2 sides. So when I only know one side, but I need 2 sides, I want to use proportions. Okay. So you put your reference angle in parentheses here. And you're going to find the O here, and you're going to find the H here, similar to when you find the X and Y. But you're going to put that with the A because you know the A value. Okay. Oh, sorry, I forgot to write the Sohcahtoa. You should do that right from the start. So sine, cosine, and tangent. So O and A would be the tangent function. Put a 1. Remember, that's O over A. Okay, so I'm finding the O. A is replaced with 12. That's why you got to have A in there. So O equals, so I'm going to take the tangent of 37 times 12 divided by 1. Okay? So tan 37 times 12 divided by 1. Okay? I got 9.04. So that's what O is. Okay, then the H. H and A would be the cosine. Cos, remember that's A over H though. Okay. Alright, so we're finding the H and we replace the A with 12. Okay, so then we'll be finding the H. So I take 1 times 12 divided by the cosine of 37. Okay, so 1 times 12 is 12 divided by cos 37. And I get 15.03. Remember, your H should be the longest side. Okay, now the degrees of measurement are easy. You have 90 degrees from that square angle. You have 37 degrees. And then to find the third angle, you know they add up to 180. So you take 180 minus 90 minus 37. Okay. And that gives me 53. There, it's solved. Okay, and the last problem, you're finding the area of a regular polygon. Okay? Now, there's a formula you go off of. You're going to put area equals. Okay? That's where the answer is going to be. Okay, so we have a formula. S times N times A divided by 2. Now, you got to know what these are. S is the side length, so the side length is 18. Okay. Then N is the number of sides. Well, count them. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 sides. Okay. So 8. Now, A is the apothem. Now, remember what the apothem is. It's from the center right down into the base. Okay, and then you make a right triangle out of it. Now, you have a 90-degree angle, you know that. You also know how long this base side is. What's half of 18? It'd be 9. Okay, 9 feet. Put that outside there. And you also can find the degrees, and you need to find the degrees that go inside of that angle. And the degrees are taking 360 divided by n, which is the number of sides, so divide by 8. But then you need to divide that by 2, because just dividing it by 8 finds the degrees that would be, don't draw this, just watch. That would be the degrees that are inside that. Well, if that's split in half, that's why you're dividing it by 2. So, don't draw that little dash thing I made. So 360 divided by 8 divided by 2 is 22.5 degrees. Okay, now take that triangle, and this is your apothem here. This is what you need to figure out. That's the apothem, AP. So AP, 22.5 degrees inside of that angle, and then 9 feet right there. Okay, so we need to use our Sohcahtoa. Okay, so I'll write it right here. Sohcahtoa. So sine, cosine, and tangent. You can abbreviate if you want. Okay, so this is the H, but I don't really care about the H. Now the reference, here, I'll write it here, is 22.5 degrees. Okay, so we're going to make a proportion. Okay, and O we know is 9. And then the apothem is the A. Now the A, circle that. That's what you need to figure out. Okay, so you put your reference degrees in here. You are going to cross multiply and divide to get that apothem value to put up here. Okay. Now we need to find the A, the apothem. Okay. And we want to put that with the O because I don't have a value for H. I don't know how long H is. O is where I have the number value. Okay. So A and O is the tangent. And that's O over A, not A over O. And we're finding the A, so we put 9 in for the O. Okay. So then A is easy to find. I just take 1 times 9 divided by the tangent of 22.5. Okay? So 1 times 9 divided by tan 22.5, and I came up with 21.73. Okay? So that's your A value. Okay, so put 21.73 there, and that's your apothem that you bring up here. And now you have everything you need. So 18 times 8 times 21.73, click equals, and then divide that by 2. So you get 1,564.56. And the correct label for that is square feet, feet to the second power.